All right, let's start off here on number 1. So for this one, we want to isolate the cosine squared here. So I'm going to start off by subtracting 6 from each side. So it's going to become negative 24 cosine squared t equals negative 6. And then I'm going to divide by negative 24. So then I get cosine squared t equals 1 over 4. And then we'll square root both sides. And so I'm going to say cosine of t equals plus or minus 1/2. So now I'm going to go to the unit circle. Now this is only over the interval of 0 to 2 pi, so it's just my first trip around the circle. And so for a cosine value of 1/2, I see it right here, and negative 1/2, I see it here, negative 1/2 there, and then positive 1/2 there, looking at the x value. And so it's going to be all of those answers. So I'm going to say pi over 3, comma 2 pi over 3, comma 4 pi over 3, comma 5 pi over 3. All right, next up here we see we have two cotangents, and so they're different powers, so I want to factor these. So I'm going to factor out a cotangent theta, and that leaves me with cotangent of theta plus 1 equals 0. And so I'm going to split these up, and so I can say that cotangent theta equals 0, and I can also say cotangent theta plus 1 equals 0, which would mean that cotangent theta equals negative 1. So once again, we're going 0 to 2 pi here, so I'm just going to do my first trip around the unit circle. I know that cotan is x over y. All right, so where is there an x value of 0? I would say that's up here at pi over 2 and then down here at 3 pi over 2. So that would be these ones. And then for a cotangent value of negative 1, I would say it's these two, because we're looking for that x over y to be negative 1. It should be the same x and y values, but one of them is negative. So I'm going to say that's 3 pi over 4 and also 7 pi over 4. You may have to write these in order, so just kind of looking at my order here, I can kind of just trace around the unit circle. So I would list it as pi over 2, and then 3 pi over 4, and then 3 pi over 2, and then 7 pi over 4. All right, next up here, we're going to get one side to 0, so I got 2 sine squared u minus sine u minus 1 equals 0. I'm going to move everything to the left. And then I'm going to use u substitution here. So I'm going to say 2u squared minus u minus 1. I'm just going to do this to kind of help me factor this. So I'm thinking of two numbers that multiply to a times c, which is negative 2, and add to negative 1, which is b. So it'll be negative 2 and positive 1. So I split up this middle piece. And then I bring down this as a negative 1, bring down this as 2u squared, so I only split up that middle piece. And then I do grouping here. So I have 2u times u minus 1 plus 1 times u minus 1 equals 0. So that'll be 2u plus 1, u minus 1 equals 0. And now I'm going to reinsert the signs back in there. So I got 2 sine u plus 1, and then 2, not 2 on this one, just sine u minus 1 equals 0. So then I can split these up and say that 2 sine u plus 1 equals 0, and then sine u minus 1 equals 0. And I can just solve those. So this one would say sine u equals negative 1 over 2, and this one would be sine u equals 1. So where does sine u equal negative 1/2? Well, that would be over here and over here. And where does sine u equal 1? That's only up here. And so I would get here pi over 2, 7 pi over 6, and 11 pi over 6. All right, next up here, number 4, I would get one side to 0 again. So I have tan squared x times sine x minus 3 sine x equals 0. I would then factor out a sine x here. So that'll give me tan squared x minus 3 equals 0. And then we can split this up, so I can say sine x equals 0, tan squared x minus 3 equals 0. So this one would be tan squared equals 3, and tan x equals plus or minus rad 3. Again, we're looking 0 to 2 pi here. So for the sine x equals 0 for this first one, I see that that's here at 0 and then also at pi. And then where does tan x equal rad 3? Well, I would say that's pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. The reason I took all 4 quadrants is that we have the plus or minus there. And so I can take it whether it's positive or negative, and that means all 4 quadrants. And so I would just list all of those answers out, all 6 of them. All right, next up here, number 5. I see we already have one side to 0, so I'm going to factor here. I would factor out a 2 cosine of, I think that's gamma, but I'm just going to call it y. And that would give me 2 cosine y plus 1 there. And so that would mean that 2 cosine y equals 0, and 2 cosine y plus 1 equals 0. So this would mean cosine y equals 0. This would mean cosine y equals negative 1/2. So then I can go to the unit circle. Now this is, again, only the answers between 0 and 2 pi, so you just have to find where on your first trip around there you get answers between 0 and 2 pi. I think you should get 4 answers on this one. Okay, next up here, they're asking us where does cosine x equal rad 3 over 2. It's kind of already solved for us, so I would say definitely we're looking at an answer right there and right there. But on this one, it does not say between 0 and 2 pi only, so we do need formulas here. So if I was doing my part A, I would say x equals pi over 6 and 11 pi over 6. But since we're really doing part B here, it's asking us to write these formulas. And so since these are not diameter buddies, and again, a diameter buddy would be like all the way across here, and so you can see that that's not what we're looking for. I actually need to write both of them plus 2 pi k. So I'm going to say here I'm going to say the first one, pi over 6 plus 2 pi k. And then we'll do a comma and say the second one, 11 pi over 6 plus 2 pi k. All right, next up here for me, I want to find tan theta equals negative radical 3. And so if it's negative, I would say it's either the second and the fourth quadrant. And so I would say that it's here at 2 pi over 3 and then also at 5 pi over 3. If you check those tangents, it should come out to negative rad 3. So once again, it does not restrict me between 0 and 2 pi, so I should have a formula for this. If I was doing part A, it would be 2 pi over 3 and 5 pi over 3. But since it's part B, these are, as you can see here, diameter buddies. And so I should only write the first one plus pi k, and that actually covers both of them. All right, next up here, they want me to find out where cosine theta equals negative rad 2 over 2. So I would say on my first trip around the unit circle, that would be right here and right here. And so let's see. Oh, this one actually asked for 6 specific solutions. So I already know 2 of these solutions would be 3 pi over 4 and 5 pi over 4. Now, I'm going to go ahead and pause there since I want 6 here, and I'm going to do part B. Now, these are not diameter buddies, and so I need to do each one of them. And diameter buddies, once again, they have to be across. You have to go through the center to connect them. You can see that these ones connect over here. And so I'm going to do each of them. I'm going to do 3 pi over 4 plus 2 pi k since they are not diameter buddies. And then also 5 pi over 4 plus 2 pi k. So then to find more solutions, what I need to do is start doing stuff like saying, what if k was 1? So if k was 1, that would be 3 pi over 4 plus 2 pi, which if I did a common denominator there, would be 8 pi over 4 and give me my next answer at 11 pi over 4. And so I could do the same thing over here, 5 pi over 4 plus 8 pi over 4, my other formula, adding the 2 pi. And so that's going to give me 13 pi over 4. And then I can do it with k equals 2, give me more answers. Obviously, these answers are not between 0 and 2 pi, but it did not specify that. So this one would be 3 pi over 4 plus, let's see, that would be 4 pi, so that's 16 pi over 4, giving me 19 pi over 4. And so for the other one, it would be 5 pi over 4 plus 16 pi over 4, which would be 21 pi over 4. All right, next up here, I'm going to go ahead and skip number 9. It's very similar to number 8, so you can check that out. Number 10, though, I'm going to isolate my trig function here, so sine theta equals negative 1. If I was doing part A, the only answer between 0 and 2 pi would be down here at 3 pi over 2. But since this is part B, it's asking for the formula here. Obviously, I don't even have a partner at all, so it's not a diameter buddy. So I'm going to just do the first one plus 2 pi k. All right, I'll let you guys try number 11. I'll go ahead and do number 12. So this one would say tan squared theta equals 3. And if I take a square root there, tan theta equals plus or minus rad 3. And so if I was doing part A between 0 and 2 pi, that would be all of the pi over 3's here, since it is plus or minus. But since it is part B, it's asking for the formula for all solutions. I'm going to match those up with their diameter buddies, which everyone does have here. These two are diameter buddies and these two. So on each of those, I'm going to say the first one plus pi k. And then I'll do it again for the second group. The first one plus pi k. All right, next up, number 13. So this one is, again, asking for all the solutions. So that's really kind of part B. So I'm going to isolate the trig function first. We'll take a square root, so then cosine x equals rad 3 over 2 with a plus or minus. Since I can do that rad 4 on the bottom, I'm just going to keep the rad on the 3. And so that tells me that we got the pi over 6's here for cosine. And I do have diameter buddies here, so I'm just going to do the first one plus pi k. And then I'll do these two diameter buddies as well, the first one plus pi k. All right, next up here, same idea. I'll go ahead and isolate that trig function there. So that's going to equal 4 over 3, and then I'll square root it. So that means that cosecant theta equals 2 over rad 3 with a plus or minus there. You could look for the cosine there. How I would change this is I would change this into sine of theta equals plus or minus rad 3 over 2. Because if the cosecant was 2 over rad 3, that means that the sine is rad 3 over 2. So however you want to look at that, I think that second way makes it a little bit easier, so I'll let you guys take it from there. All right, next question here, we're going to do some factoring. So I'm just going to rewrite this as 4u squared minus 4u plus 1. I'll go ahead and do my x, and we'll have 4 on top and negative 4 on bottom for b. So it's going to be negative 2, negative 2. And that means I split up this middle one as negative 2u, negative 2u. Keep the outsides the same and then do our grouping. So I get 2u times 2u minus 1. And the second group I need to pull out a negative 1, leaving me with 2u minus 1 as well. So I actually get 2u minus 1 times 2u minus 1. And that really means it's 2 cosine x minus 1. 2 cosine x minus 1. So I did get the same thing twice, so I actually only need to set it equal to 0 once, because obviously that'll give me the same answer. And so we're looking for cosine x to equal 1/2. And so that is right here and right here. Now this one is asking for all the solutions. And so it's asking for the formulas. These are obviously not diameter buddies because they don't go through the center if you connect them. So I'd have to do the first one plus 2 pi k. And then the other one as well, plus 2 pi k. Not allowed to combine them unless they are diameter buddies. All right, next up here, we'll do some more factoring. So I'm going to call this u squared minus 5u minus 6. So we'll do the x thing again. So I got negative 6 and negative 5 for my a times c and the b. So it's going to be negative 6 and positive 1. And on this one, you can actually just do a shortcut. Since there's no a value there, you can just take these numbers and become your parentheses. So u minus 6, u plus 1. And so that becomes sine x minus 6 times sine x plus 1 equals 0, which would mean sine x would have to equal 6, and then sine x would have to equal negative 1. Now this one's impossible. Sine x never equals 6, but it does equal negative 1 at 3 pi over 2. That's just between 0 and 2 pi though, so since this is all solutions here, it doesn't restrict it. It's going to say it's just going to be 3 pi over 2 plus 2 pi k. All right, so next up here we got u squared minus u minus 30 equals 0, and so I'll factor that, negative 30 and negative 1 for my a times c and my b. And so it's going to be negative 6 and positive 1, so I can just write this as u minus 6, do my shortcut, u plus 5. And so that would mean cosine x minus 6, and then cosine x plus 5 equals 0, So it's asking where does cosine x minus 6 equal 0, and where does cosine x plus 5 equal 0. So that's asking where does cosine x equal 6 and cosine x equal negative 5. And so neither of those will ever happen, so this one is going to be a no solution. All right, number 20, I actually see it's already factored for you, so you can actually just split this up right now and set them equal to 0 individually. And this one is asking you for, I'll let you guys solve that, but I'll just say it's asking for part B because it doesn't restrict it between 0 and 2 pi. All right, number 21 here, I see that this is equal to 0, so I'm going to factor out a sine theta, which leaves me with cosine theta minus 8 equals 0. So now I can just split those up. So this one is sine theta equals 0. This one's cosine theta minus 8 equals 0, which means cosine theta equals 8. Now that's not going to give me any solutions, but for sine theta equals 0, that is at 0 and at pi, or I should say theta equals 0 and pi. And I want to combine that in a formula. So since these are diameter buddies, I'm going to say the first one plus pi k. But since that first one is really 0, I would actually just write pi k here, since adding 0 doesn't really change anything. All right, now we're switching over to inverse here, which is kind of similar to solving equations, except for one big factor, which is for sine and tan, we're only allowed to look in the first and the fourth quadrants. And then remember that for cosine, we look in the first and the second quadrants. So for the trig equations, but especially between 0 and 2 pi, obviously, we're going to look at the whole circle. But on these ones, we're restricted. So sine inverse of negative 1/2 would be right here at 7 pi over 4. However, we do not call that one 7 pi over 4. We actually call it negative pi over 4 because we want the answer closest to 0. So we always call those fourth quadrant ones negative. Now, cosine inverse of negative 1/2, it would be over here. But these ones, remember, we do not do that negative trick. We're just going to call it 2 pi over 3. And so I'll let you guys try part C. All right, and then so now 23, same idea here with arc is the same thing as inverse. Remember, we're going to look in the first and the fourth quadrant for sine and tan, and we're going to look at the first and the second quadrant for cosine. So for arc sine of rad 3 over 2, it's just right here, and it would just be pi over 3. All right, next up here, we got some more inverse stuff, so we're just going to do it piece by piece. So the inside here, I have cosine inverse of negative 1/2, so that is over here, and so that one's going to be a 2 pi over 3. And so now I just have to do the outside, which is still a sine there, and you just need to take care of that. And so obviously the sine of that same spot would be rad 3 over 2. I'll go ahead and jump down and do C here. So sine inverse of 1 would be up here at pi over 2. So this is asking me for tangent of pi over 2. Let's do the inside first, and then now I'll do tangent of pi over 2, which is 1 over 0, which is undefined. All right, next up here, let's see. We're going to have to solve this equation. So we need to multiply this by negative rad 3 over 2 to both sides. So we're looking for cosine of 3 theta to equal negative rad 3 over 2. And so I'm ready to go to the unit circle now. And I see that this was true at 7 pi over 6 and then also 5 pi over 6. Now these are not diameter buddies, so I'm going to do, I have to start right now by saying 3 theta equals, and I have to do each one on their own plus 2 pi k. So 3 theta also equals 5 pi over 6. Nope, that one will be 7 pi over 6 plus 2 pi k. So since the inside here was 3 theta, I need to include that now in my formula. And before I write my answer, I need to get rid of this 3, which I'm going to do by multiplying by 1/3. So this one would be, let's see, that would be 5 pi over 18 plus 2 pi over 3k. And then this one over here, if I distribute that in, would be 7 pi over 18 plus 2 pi over 3k. So that's my answer for the part A here. And now to find part B, I need to start plugging in values of k here. So I'm going to do it first. I'm going to take these formulas, and I'm going to do it first as k equals, well, actually I should do it as k equals 0. That's actually really easy. And so that one would be just the 5 pi over 18 and then the 7 pi over 18. So that's my first two there. All right, so now I need to do it as k equals 1. So that's going to be 5 pi over 18 plus 2 pi over 3, just inserting 1 for k. Now, of course, we're going to want a common denominator here, so we'll multiply by 6. So it's going to be 12 pi over 18. And so that'll give me 17 pi over 18. All right, now I need to do the other formula, 7 pi over 18, and then add the 2 pi over 3, or 12 pi over 18 there. So it's going to give me 19 pi over 18. And now I'm going to do this again with k equals 2. So we'll do 5 pi over 18 plus, and that'll just double that 12 pi over 18, so now it's going to be 24 pi over 18. Which will give me 29 pi over 18. And then I'll do it again as the 7 pi over 18 plus 24 pi over 18. And that's going to give me 31 pi over 18. I can try it again as k equals 3, but when I try the first one here, it's 5 pi over 18. Let's see, that would be 36 pi over 18. And I can already see that that's going to be 41 pi over 18, which is not between 0 and 2 pi, so I know my list is already done. All right, next up here, I would, on number 28, I would just change everything into sines and cosines. So I'm going to say 1 over sine minus sine over 1 over cosine over sine. And then we'll go ahead and do a common denominator up here. So it's going to be 1 minus sine squared over sine over cosine over sine. And I know I can change that into cosine squared over sine over cosine over sine. We'll go ahead and multiply by the reciprocal there. And we can cancel these out, partially cancel there, and should be left with cosine x. All right, next up here, I would change this, I can't change that, but I would change this into 1 over sine. And I would get a common denominator, so this one's going to multiply by 1 minus cosine. And this one's going to multiply by sine. And I need to make sure I distribute this as a -1 there, so this is going to become sine squared minus 1 plus cosine over sine times 1 minus cosine. Okay, what do I see next? I guess what I would do, oh, I see it, okay. Oh, no, I don't. All right, so I know that 1 minus sine squared equals cosine squared. Now, I actually don't have that, but if I multiply everything by -1, then I have -1 plus sine squared equals negative cosine squared. So I can use that here by taking this out and turning it into negative cosine squared plus cosine over sine times 1 minus cosine, which then on that numerator I can factor out a cosine, which leaves me with negative cosine plus 1 over sine times 1 minus cosine. And these are actually the same, so I can cancel them out. So I'm left with cosine over sine, which is cotangent of t. All right, lastly, number 30 here. So for this one, I want to factor out a cosine x, leaving me with cosine squared x plus sine squared x. And that is, of course, 1 in there. So 1 times cosine x is just cosine x.